Everybody, it's Mourad Sultan Ezouidi, the mathematics teacher, the researcher in the field of polynomials. Okay, today, inshallah, as usual, I promised you that I will handle with, let's say, polynomial to the power 6, so that we can, let's say, find all the roots of any polynomial to the power 6. Okay, and today you are, let's say, um, we are, let's say, glad to theories, okay, with you, okay, and at the same time we solve and find out all the roots of any polynomial to the power 6, okay. So therefore, we start learners, okay. I'll just comes here, it comes to this polynomial to 6, okay. This is polynomial already prepared for you, okay, involving the discriminant formula of Mr. Mourad Sultan Ezouidi. Okay, just comes here. Okay, we start from this. Okay, okay, this is our polynomial to the power 6 that we are going to solve. Okay, polynomial example number 6. You can see this polynomial to the power 6 has been written here. Okay, and we are going to find all the roots of this polynomial to the power 6. First of all, I can write my, let's say, original polynomial as the following: p of x equal x raised to the power 6 minus L0 of ODQ, okay, x raised to the power 5 plus L1 of ODQ x raised to the power 4, okay. Then learners, okay, sorry, then minus L2 of order uh, q x cubed plus L3 of order q x squared minus L4 of order q times x plus L5 of order q. You can, let's say, if you are going to equate the first polynomial to the second one, you will get, let's say, L0 of order q is 1, L1 is 15 over 36, L2 is 20 over 216, L3 is equal to 15 over 1,296, and L4 of order Q is 26 over 6 raised to the power 5, and the last term L5 of order Q is equal to negative 31 over 6 raised to the power 5. Okay, just I'll check here. Okay, then learners, we can start now, let's say, solving a polynomial to the power, of course, to the power 6. Okay, uh, okay. Mhm. So we told that yes, this is our polynomial to the power 6 that we are going to solve. Okay, I'll just make this is mute. Okay, so therefore, learners, so we should start. Okay, okay, I will start. Okay, there is a problem in stream. I'll check my stream. What happened? So okay, I will come here. I'll check just a moment. I'll check this one. Okay. So it's an occasion for all the learners, okay, and the professors to use the method of Mourad Sultan Ezouidi, so that find out all the of any polynomial to the power 6. Okay, I'll just see this one. Okay, live. Mhm. We'll start within, let's say, 30 seconds. Okay. Okay, yes, default Microsoft. Okay, let's see what happened here. I'll check this one. Say polynomial the power to the power 6. Okay, we continue. Okay, restarted. It was okay. Okay, device stop it. Power 6 that we are going to solve learners is that. So first of all, let's focus on this one, learners. Okay, let's focus on the following. We can say that this polynomial, let's say its highest power is 6, so it's a polynomial to the power 6. So in order to find, let's say, out the roots of this polynomial, we should find, let's say, or determine the values of SR for the Q relative to LR for the Q, where R learners belongs to the set of numbers from -1 to 5. Okay, then learners we can adjust. Okay, make it bigger for you. Okay, like that, so everyone can see. Okay, yes, I thought that's more bigger. Okay, it's enough. Then here, learners, I will just now start using the discriminant formula of Mr. Mourad Sultan Ezouidi that he had discovered one day. And this method is very important for finding out all the roots of any polynomial. Okay, not only 6 or 7 or whatsoever, but in fact is for any, for let's say, all the polynomial to the power n. The formula is that sk minus 1 of order r equal the sum from 0 to k, combination n minus r, choose k minus r, n raised to the power r times, between parentheses, minus l, okay, minus l. Yaqeen, my daughter Yaqeen, please come, hurry up. Please, please, please. Hurry up, Yaqeen. Okay, please, one coffee. Hurry up. Okay, and close the. Okay, thank you. So therefore, we told that into parentheses minus L0 for the Q raised to the power K minus R times LR minus 1 of all the Q. Now we are going to replace K with 0, then with 1, then with 2, then with 3, 4, and 5 to get all the SR of all the Q relative to LR of all the Q. We said for K learners equal 0, we'll obtain immediately, let's say, immediately we'll obtain S minus 1 of order I is 1. Okay. Now I'm going to set K equal 1 to find the value of S0. Okay. So when K equal 1 learns, thank you, Dr. K, put it in. Thank you. Okay, when R, we told that IK dot, thank you for your help, IK. So we told that for k equal 1 learners, we write S0 of order R is the sum from 0 to 1, okay, combination n minus R, 1 minus R, n raised to the power R times minus L0 of order Q, let's say raised to the power 1 minus R, L, R minus 1 of order Q. Now, just make distribution, okay, or simplify what is given inside the sum, and you will get, let's say, combination n choose 1, n raised to the power 0 times, between parentheses, negative L0 of order Q, let's say, okay, of order Q, times what, learners? Times what, learners? Times L minus 1 of order Q plus, when let's say R equal 1, okay, and the last one means K, it will be combination n minus 1 choose 0, which is 1 in fact, times n raised to the power 1 times negative L0 of order Q raised to the power 0, which is 1, times L0 of order Q. You can see, learners, that this one is a common factor, and that it's a common factor. I put them outside the brackets, either written in, let's say, on the right hand side or in front of the bracket. Okay, means in the back or in front. Therefore, this one will give us, learners, minus n choose 1 L0 of order Q times L minus 1 of order Q plus n L0 of order Q. I will put this as a common factor. Therefore, I will obtain n minus n is 0, multiplied by a number that is different to 0, which is equal to 0. This is S0 of order R, learners, of any polynomial has to be equal to 0, because this is the formula, the discriminant formula of Mourad Sultan Ezouidi, by convention. That's in fact is a 0 here. Okay, now, learners, after that we should, let's say, calculate it. I will use the coefficient of my own polynomial, okay, raised to the power 6, to calculate S1, okay, because this is calculation. The formula, let's say, leads to 0, okay, and also you should, let's say, find it in numerical value. Means S0 of order R, learners, is negative 6 choose 1 times L0 of order Q is 1. I will replace L0 of order Q is 1. I will replace 1 plus 6 times 1 gives, let's say, negative 6 plus 6 equals 0. Therefore, learners, we just obtain the value of S0, which is, learners, 0. Okay. Now, we have to find also S1, which is very important. S1, learners, okay, we should find S1. Just, okay, S1, learners, okay, just give me this one, okay. S1, learners, is that this is S1, okay. What happened to this? Okay, I will try to appear this with green color, okay, because this one, S1, has been derived from the discriminant formula when k equal 2. Okay, so S1 is the sum of from 0 to 2, combination n minus r choose 2 minus r, n raised to the power r times negative L0 for the q raised to the power 2 minus r, LR minus 1 over the q. This one, learners, after calculation and simplifying, it will be equal to immediately a combination n choose 2, L0 for the q square minus n, okay, combination n minus 1 choose 1, L0 for the q raised to the power 1 times L0 for the q plus n squared L1 of the q. You can see this one, you see this one, L0 for the q raised to the power 1 times L0 for the q, in fact, is equal to L0 for the q squared, means this and that, let's call it common factor. I should put this common factor outside the bracket. Okay, I will write as combination n choose 2. N here, in fact, is 6 because opponent to the power 6. And its highest power is 6, okay, minus n times cn minus 1, choose 1 times, I close parenthesis, L0 for the q squared plus n squared L1 of O the q. This is, learners, is the discriminant formula that has been derived from the discriminant formula of Mourad Sultan Ezouidi. Okay, And the C is its very important formula for which you can find the value of S1. Okay. Now, learners, I will use, let's say, the coefficient. I will use just L1 and L0 because in the formula, you should just replace L0 with its value and L1 with its value. Okay. No need for L2, L3, L4, L5, and L6. That's why S1, the S1, let's say, of ODQ, only the value that we are going to substitute is L0 and L1. Therefore, I should, let's say, continue solving this one. I'll go back, learners. Okay. Therefore, I will use, let's say, okay, my calculator. Okay. My calculator, let's say, learners will set the following. We have a negative combination. 1 choose 1 is 1 times 15, okay, times 1 plus 6 squared divided by 36. It will be cancelled out times 15, okay. I will use my calculator. It will be negative 15 times 1 squared, okay, times 1 squared, no problem, I write it, plus 15, okay. This one, learners, should be equal to 0, okay. Therefore, the value of S1, learners, is 0, okay. Now we calculated the value of S1 and we calculate also the value of S0, okay, and the value of S minus 1. Therefore, learners, here to continue proceeding finding the value of S2 and S3, okay, we should learners setting k equal 3, means that this is very important, learners, okay, very important, okay, to set, let's say, k equal 3, means that you are going to find the value of S2. Of course, the value of S2 that will be derived from the discriminant formula of Mourad. Okay. Now let's start. S2 of order R is the sum from 0, okay, raised to 3, of course, combination n minus r, 3 minus r, where r, let's say, belongs to 0 and 3, okay, means 0, 1, 2, 3, okay. Therefore, times n raised to the power r, between parentheses, negative L0 for the q, all raised to the power 3 minus r times L r minus 1 of O the q. Q, learns here can be, let's say, varied, okay? Okay, and this one, I will explain this one maybe in the coming days, okay, in the future, where k varies, so everything will give you the, let's say, the powers of the zero of polynomial k, and we'll get also a new polynomial with this new order, okay. Therefore, this one should be equal, learns to what? Negative combination, choose 3, L0 of O the q raised to the power 3 plus n, combination n minus 1 choose 2, because n minus 1 means r is 1, n minus 1, then 3 minus 1 is 2, and n raised to the power 1, okay, times L0 of O the q, 3 minus 1 is 2, times L1 minus 1 is L0 for the q from the formula of Mourad Sultan Ezouidi. Okay, minus combination n minus 2, choose 1, n squared L0 of ODQ raised to the power 1 times L1 of ODQ plus, learners, you can see this one, n cubed, because when r equal 3, I will get n cubed, and 3 minus 3 is 0, therefore n minus 1 choose 0 is 1. That's why I didn't write here combination like that combination 0 n minus 3 because it's 1. Okay, n raised to the power 3 because r is 3. This one also, learners, is 3 minus 3 is 0, and in any value that is different to 0 raised to the power 0 is 1. That's why here I neglectate the 1 here because it's clear for you as mathematics students and teachers and professors. Okay, times when r equal 3, it will be 3 minus 1. That's why here had been written 2 about the q. Okay, now learns we can see that L0 for the q raised to the power 3 here in this term, and that term it's called a common factor. I'll put them outside the brackets. Either this has will have been written in front or on the back of the brackets, or in other words, written in on the right hand side or left hand side. This never no mind. Okay, never mind if you are going to do like that. Therefore, here L0 of the Q, the common factor raised to the power 3, is written on the left hand side of the bracket. Okay, it remains now negative. Okay, n choose 3. Okay, then plus n minus 1 choose 2. Then I close the parentheses. Minus learners what? I cancel this one. I simplify this one. Therefore, I'll just continue. It will be negative n minus 2, choose 1 times n square, okay, times n0 of O D Q raised to the power 1 is written here, times L1 of O D Q plus the last term is n cubed L2 of O D Q. This one, learners, you can see, okay, if you want to calculate this in general, learners, okay, this one has to be equal combination of 1, 2, 2 choose 1, which is 2 in fact, combination, and choose 3 times the common factor, which is called L0 for the Q raised to the power 3, minus combination and minus 2 choose 1 times the square of n times L0 of O D Q, of course, times L1 of O D Q plus n cubed L2. Now, learners, I will use this fact. Here in this example, I will just use 3 coefficient, okay? I will use L0, L1, and L2, okay? But I will give a blue color for the whole, for the other terms also, okay? This is never mind, okay? No, 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 Mr. Murad, don't like that, okay? Sorry, sorry. Okay, I will begin again. Okay, I will change the color. Okay, I hope so this one will work. Okay, now I change Mr. Murad. It will be like that. Okay, no problem. Therefore, learners, our outcome is now to find the value of S2. S2 is very important because if you want to solve any polynomial to the power 6, you should or you have to find all the value of SR okay, of O D Q relative respectively to LR of O D Q that is given from the beginning. Okay, now I will just use my calculation. I will check. Okay, I will. Where is the calculator? Okay, this is my calculator. Therefore, learns I will start from this. Okay, I will write 2 times 20. Okay, minus 40. I'll just write 40 times 1 cubed. Okay, if you want, I will write it 1 cubed. Okay, raised to the power 3 minus. And then negative 4 times 6 squared, multiply by 1, multiply by 50, divide by 6 squared. You see 6 squared and 6 squared, you can cancel them out. Just you will write 4 times 15. I'll just write minus negative sign. 4 times 1, okay, times 15. Why? Simply because 6 squared divided by 6 squared is 1. Then plus what? 6 cubed multiplied by 20 divided by 6 cubed. 6 cubed and 6 cubed, it will be cancelled out. I'll just write plus 20. Therefore, plus 20. This one learns is equal to numerically or automatically. Numerically, I prefer spelling, saying it like that. Numerically means automatically. Numerically, okay, good man. So this one learns is 0. You see, is the correct now. Okay, it's the now. Okay, now close this one. Then going to find the value of S3. To find S3 learns, there are some steps that everyone has to follow using the method of the discriminant formula of Mourad. Okay, and this discriminant formula, let's say, tells you that you should practice this formula so many times, okay, so that you can memorize or yes, memorize it in your mind, okay, to be a smart person or learner or student or teacher or professor to work with this kind of formula, okay. Therefore, learners, I'm going to set k equal 4 to find what, in your opinion, to find, let's say, to find the value of S3, okay. Therefore, I should set this one, learners, okay. I will come here. I will, okay, find the value of S3. I will just set, we told k equal learners equal 3, 4. It means S4 minus 1 is S3 of all the R, let's say, runs or started at 0 and ends at 4. Combination n minus R, 4, choose 4 minus R, n raised to the power of R times between parentheses negative at 0 for the q raised to the power 4 minus r times lr minus 1 for the q. This formula, it's called the discriminant formula of Mourad Sultan Ezouidi. And let's say, let's say, let's say, and with this formula, we can solve the polynomial. Okay. And what else? We continue. When r equals 0 learners, I will get the combination and choose 4. L0 of order q raised to the power 4. When r equal 1, I will get n raised to the power 1 times combination n minus 1, choose 3 times L0 of order q raised to the power 3 times L0 of order q. Plus learners, when r equal 2, I will obtain immediately combination n minus 2, choose 2, n squared, L0 of all the q raised to the power 2 times L1 minus when r equal 3, I will get n minus 3 combination, choose 4 minus 3 is 1, okay, times n raised to the power 3, okay, because r is 3, it will be n cubed times L0 of all the q. 4 minus 3 is 1 raised to the power 1 times 3 minus 1 is L2 of O the cube. Okay, now learn the last term is that when r equal 4, 4 minus 4 is 0, n minus 4 means this combination n minus 4, okay, choose 0 is 1 times n raised to the power 4. That's why here it's written n raised to the power 4 times, you see this term, negative L0 of the q raised to the power 4 minus 4 is 0. And any value raised to the power 0 and this value has to be different to 0, should be equal to 1. That's why here we simplified and we didn't appear that is 1. It's clear for you that it's 1. Therefore, multiply by L3 for the q. Now you can, let's say, continue simplifying learners. You can see that L0 for the q raised to the power 4 is the same as L0 for the q raised to the power 3 multiplied by L0 for the q, means I should put this outside the brackets because it's called a common factor, okay, between these two terms that is raised 1 for 4 and 3. Okay, I will put here 0 for the q raised to the power 4 times combination choose 4 minus n combination n minus 1 choose 3, then plus the last, which is the rest, sorry, which is combination n minus 2. Okay, choose 2 and squared, okay, because it's written here, times L0 for the q, okay, squared times L1 minus learners, okay, negative combination. Okay, this is combination, Mr. Mourad Sultan. Okay, we told that. What is it exactly? Combination. Up. Okay, okay. I told that n minus 1, n minus 2, n minus 3, correct. Then 3, 2, 1. Yes, correct. So, yes, it's correct. This one, okay, we'll close this. Plus, okay. Mm-hmm. Here, I mean this one. I will go down. I will make it this one. This one is one. Okay. Yes. So I will close this one. Therefore, C combination n minus 1, okay, n minus, okay, plus combination n minus 2, which is 2, n squared, n 0. Then here, combination, and when n equal 3 learns, it will be n minus 3, yes, n minus 3, okay. This one we told, okay, it's written here, n minus 3, okay. It comes up. Where exactly? I will just make it bigger for you to see it again. Okay, like that. Okay, I will come here to appear first. I will change the size full. Okay, okay, we told that. This is okay, C4n, okay, n minus 1, 2n minus 2, okay, then 1n minus 3, correct. Therefore, here, so it comes here, if it is possible, okay, C3n minus 1, because the C3, then okay, 2n minus 2, then 1n minus 1, okay, correct here. So what is the 3 here? That is written, okay, this one learns, yes, n minus, just a moment, okay, minus 1, minus 2, C1 minus 3, yes, C1 minus 3, okay, it will be Cn minus 3, correct, خلاص. لا, no, like that, down, okay. Now we clicked it, okay, خلاص, it's repaired. Sorry, again, Control A, okay, change the size, okay, subscript, okay, good man. Therefore, learners, we obtain this one. I will now continue to find the value of S3, okay, of S3, okay, to find, okay, I should, let's say, substitute, okay, substitute L0, L1, L2, L3 with their own values. Right? I will continue doing like that. Okay, I will calculate means I should calculate this. This is S3. I will use the calculator. Okay, I will erase okay, this one. It will be negative, learners. This is 3 times 15 is 45. Negative 45 times 1 raised to the power 4 is none, never change, just negative 45. Plus, learners, combination 4 choose 2 is 6. Times what, learners? Times 15. Why? Because here 36 over 36 is 1, 1 squared is 1, so it remains the same. Minus 3 times 1 times 20 means minus 3 times 1 is 3 times 20 minus 60. Minus 60, 60. Then plus, learners, okay, 6 raised to the power 4 divided by 6 raised to the power 4 is 1 times 15. I will just make plus 15. This one should be equal to, okay, negative 180. Negative 180. Okay, negative 180. This is S3. Just a moment, I'll check again. Okay, it will be negative 3. This is negative 45. Negative 45 plus what, learners? Negative 45. Okay, plus 6 times, yes, 6 times 15 plus 6 times 15 plus 6 times 15. This one plus 6 times 15 minus 3 times 20 minus 3 times 20 minus 3 times 20. Why? Because this is a combination 1, 2, 3 times 20 plus learns 15 plus 15. This one should be equal learns to what? To 0. Therefore, the value of S3 is 0. Okay. Now, I will close this one and then I should proceed to find new the value of S4. Okay. To find S4 learns, you should set K equal 5. Very important, this one. Okay. Till now, we didn't finish finding the value of S R for the Q. Therefore, learners, I will use this fact, okay? I will use I will use this color. Okay, it's good, this color, okay? And therefore, to find S4, you should put K equal 5 in the discriminant formula of Mourad Sultan Ezouidi, HSM. So it would be R from 0 to 5, combination N minus R, 5 minus R, N raised to the power R, negative L0 of ODQ raised to the power 5 minus R times L R minus 1 of ODQ. This one learns step by step. You will get the following. The last answer, which is S4, that implies that S4 equal learners. Okay, I will try to like that. Okay, so it will be clear for you. Let's see. Okay, so now learns when k equal with that, this implies that S4 of order R is 4 times combination n choose 5 and 0 for order q raised to the power 5 minus combination n minus 2 choose 3 n squared and 0 for order q cubed and 1 for the q plus combination n minus 3 choose 2 and cubed and 0 for the q raised to the power 2 and 2 minus n minus 1 choose 1 and to the power 4 L0 for the Q, L3 for the Q, plus N raised to the power 5 and 4 for the Q. We start from the beginning if you want. When R equals 0, it will be combination 5 minus 0, N minus 0, okay. Therefore, it will be written as combination N choose 5, and the minus 1 comes, the minus negative sign comes, negative L0 for the Q to the power 5 minus 0. This one, the raised power is odd number. That's why the negative sign, I wrote it in front of the term combination Cn minus Cn minus 0, 5 minus 0. Choose 5 minus 0 means combination n choose 5 and 0 for the q raised to the power 5 plus when r equal 1, I will obtain n raised to the power 1. Okay, combination n minus 1 choose 5 minus 1 is 4. Okay, is 4. Okay, like that. Okay, is 4 times L0 for the q raised to the power 4 L0 for the q. Only this one, and that will conclude that is a common factor, and we should put it outside the brackets, and we simplify the first two terms. Minus learns what? Minus n minus 2 choose 3 n squared and 0 for the q cubed and 1 for the q plus combination n minus 3 choose 2 n cubed and 0 for the q raised to the power 2 and 2 for the q minus combination n minus 4 choose 1 and raised to the power 4 and 0 for the q raised to the power 1 and 3 of the q plus last term is n raised to the power 5 and 4 of all the q. Okay, this one I can simplify, learners. I will just simplify the first two terms, but the rest will be written as it is, no change. You can see this one, negative combination n minus 2 choose 3 up to L4 is written here, no change. Okay, therefore I will just change this one if it is possible. Of course, I will write L0 for the 5 raised to the power, or the q raised to the power 5, learners, multiplied by negative combination n choose 5 plus n combination n minus 1 choose 4. This term, learners, is just in fact the combination 4 choose 1. Okay, there is a secret in fact. You see, as 4, that's why here you should write combination 1, 4 choose 1. And 4 is even number, so there is no negative sign. Okay, okay. Look, if for example here 3 like that, 3 you should appear the negative sign here. It will be combination 3 choose 1, then 3 plus 1 gives you 4 and 6. Okay, this is the secret. Okay, of Master Mourad Sultan Ezouidi in this formula. Many secret in fact. Okay, but I will release this secret for you. I will give you these keys of work. Okay, so S4 raised to the power R is combination 4 choose 1, combination n choose 5, and 0 for the q raised to the power 5 minus all of this. We told there is no change in it, is the same as that. Okay, is the same as that. Okay, now learners, I will just after, let's say, simplifying the value of the formula, the discriminant formula of Mr. Mourad Sultan Ezouidi, when k equal 5, I obtain this one. Okay, I will use the last one to find the value of S4. Okay, so prepare a calculator, learners, with your teacher, Mourad Sultan Ezouidi, because you are going to learn new method. Okay, and these methods now are, let's say, are like a gift. Okay, it's you can use it. Okay, to solve polynomial. Okay, therefore learners. Okay, we continue. Okay, okay. Therefore, I will use this one. It's very important, learners, to find the value of S4. After that, we should find the value of S5. Okay, I will use this one, learners. I will make it bigger for you so that everyone can see. Okay, even if okay, 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 okay. Okay, I will now start. Okay, okay, I will use my calculator. Therefore, the calculator tells you that you should find the value of S4 raised to the power R. Learners, the R can vary, in fact. Okay, and if the R varies, means that we'll get new polynomial. Okay, and the zero or the roots of this polynomial has been raised to the power R. You see, okay, this one I will explain one day. Okay, let's proceed. We'll just write combination 4 choose 1 means 4. I will write immediately 4 times, learners, combination 6 times choose 5 is 6 times 6 means 24. Okay, times 1 cubed, 1 raised to the power 5, okay, is 1, but I'm going to write it as it is so that the learner or the learner, yes, or the teacher or the professor or the student that he is now, let's say, watching, he has to think that the one, in fact, is L0 for the Q. Okay, it's not 10, it's not 100, it's the one, the real, the correct value of L0 for the Q. Okay, then learners minus what? Minus, you can see 4 choose 3 is 4 times 6 square. Okay, 6 square divided by 6 square. I, let's say, jump this step. Okay, because it's 1. I can just write times L0 of O q raised to the power 3 means 1 times, learners, 1 raised to the power 4, 3, Mr. Mourad. Okay, times what? Times, we told 15. Okay, then we finish the first term and the second term. So it remains for us. It remains for us to continue calculating what is the rest. Means that plus, yes, daughter, want something? Okay. So plus 3 choose 2 means 3. Okay, we just write plus 3. times what, learners? Times 6 cubed divided by 6 cubed, خلاص, will be cancelled out, times 1 squared, times 1 square, okay, times, learners, 20, times 20, okay. Therefore, minus 2 times 1 times 15, this 6 4 to be cancelled out. Okay, so minus, please don't make noise, my daughter. Okay, minus 2 times 1 times 15. Okay, therefore, plus 6 raised to the power 5 divided by 6 raised to the power 5 is 1. I'll just write plus negative is negative. I'll just write minus, learners, negative 26. Minus negative 26. Okay, this one should be equal to negative 232. Okay, negative 232. I'll just check again. If it is negative 232, okay, I will erase everything. I'll just write 4 times 6, 24, okay, times 1. I now need to write it. Negative 4 times 15 means negative 60, okay. Then plus 3 times 20 plus 60, okay, because 3 times 20, 60, minus, learners, 15, minus 15, minus 26, minus 26. Okay, this one, learners, should be equal to negative 17. Okay, equal negative 17. Okay, okay, I will write it negative 17. Okay, negative 17. I will repeat this again. Okay, therefore, okay, I will cancel this. I will start now from this. Negative 26. I'll just check this one if it is negative 26 or not. Okay. Negative, yes, negative 26. Or I will use it from here. Okay. I will just put, oh my God. Okay. Like that. So this is the formula. We told, okay, this is 24. Okay, I will repeat again. 24. Okay, minus 4 times 15 is minus 60. Then, learners, okay, because this is 15, plus 3 times 20, plus 3 times 20, plus 60, okay, minus 2 times 15 is, okay, yes, minus 2, the formula, give what is the formula, okay, the formula, we told, okay, 1465, correct, then minus 4 choose 3, 4 choose 3, correct, then plus, okay, 3 choose 2, 3 choose 2, correct, okay, okay, correct, 20, then minus, and 2 choose 1, 2 choose 1, yes, okay, 15, 15, yes, correct. The last one, n raised to the power 6 raised to the power 5 times L4. L4 is negative, okay, is negative 26. Okay, let's see. Therefore, I will continue. We told that negative 24, 24. Why negative 24, Mr. Murad? Yes, just a moment. Here is 24 emitted. There is no negative sign. Okay, I will make 24 minus 4 times 15 is minus 60. Then 3 times 20 plus 60 plus 60. Then, learners, minus, okay, 24 minus 4 times 15 is minus 60. 3 times 20 is plus 60. Minus 2 times 15 is minus 30. Then, okay, minus 26. Minus 26. Minus 26. So this one should be equal to negative 32, as it is written from the beginning by the calculator. Sometimes online will give you mistake. Okay, so it's written as negative 32, and this is the correct answer. You see, learners, when you are online, the intelligence, the artificial intelligence can, let's say, change your, okay, change something for you, but I'm very intelligent, more than the AI. Okay, therefore, we obtain this negative, okay, it will be negative 32, okay. Therefore, if you want to repeat this for you, I will repeat this for you. So that will be confused, okay, persuaded, yes. Therefore, I will just make like that, learners. I will repeat this for you in front of you to find the value of this. First of all, comes here, Mr. Murad. Yes, good man. Go, 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 go. Okay. I will write it again. Okay. I will write it differently if you want. I will write this one as, okay, okay, okay. I will use the calculator. So we told that this one learns combination 4 choose 1, combination 6 choose 5 is 24. This one is 24. I will write immediately 24. Minus 4 times 15 is minus 60. Then plus 3 times 20 is plus 60. Here. Then minus 2 times 15 is minus 30. And minus 26. The last one, minus 26. So this one is negative 32, and we close this parenthesis. Okay, so S4 is negative 32. Now, to find the value of S5, we should, let's say, set K equal 6 to find S5. Therefore, learners, outcome is here. I should find the value of S5 using that has been derived from the formula, discriminant formula of Mourad Sultan Ezouidi. Okay, there is something that does not appear here. I will try to appear it. This one I will put it here. Okay, and this one also I put it. Okay, that this one no problem. I will let them back, but this one is too long. Okay, I will put like that. I will close this one. Therefore, now learners, when putting, let's say, k equal 6 means 6 minus 1 is 5. So S5 of order R is the sum that R runs or started at 0 and ends at 6. Combination n minus R, choose 6 minus R and raised to the power R times negative L0 of all the Q's, raised to the power 6 minus R, then multiply by LR minus 1 of all the Q. This one, if you want to simplify or distribute the value, distribute this formula, this kind of formula, Mourad Sultan Ezouidi, you'll obtain a combination n choose 6 and 0 for the q raised to the power 6 minus n combination n minus 1 chooses 5 and 0 for the q raised to the power 5 times and 0 for the q raised to the power 1, and this one gives you a term raised to the power 6 and the big and the first, so it's a common factor. Okay, plus combination n minus 2 choose 4 times n squared. Okay, times L0 of the q raised to the power 4 times L1 of the q minus combination n minus 3 choose 3, because R is 3, n minus 3, and 6 minus 3 is 3. Then n raised to the power R is 3, it will be n cubed. L0 of the q, 6 minus 3 is will be 3 here times. Therefore, it will be okay. 2 of all the cube plus combination n minus 4 choose 2 okay, choose 2 total, n raised to the power 4 times and 0 for the q raised to the power 2 times and 3 of the q plus, don't forget, r minus combination n minus 5. When r equals 5, it will be n minus 5, and 6 minus 5 is 1. That's why he is written 1. You see the negative sign, because negative L0 for the q to the power 6 minus 5 gives 1. And a number, a negative number raised to the power an odd number, let's say it will carries with it, let's say, the negative sign. That's why I wrote here the negative sign combination n minus 5. choose 1 and raised to the power 5, L0 of O, the Q raised to the power 1, L4, okay, L4, okay, L4 means 5 minus 1, L4 of O, the Q plus, when now n equals 6, you can see that n minus 6, then 6 minus 6 is 0. So this one is 1. Okay, and raised to the power 6 times L5 over dq. You see all of these learners from the combination n minus 2 up to the combination n minus 6 has to be written as it is, not changed. But the first two terms I just simplified as the following. I wrote L0 of ODQ raised to the power 6 between parentheses combination n choose 6 minus n combination n minus 1 choose 5, okay, plus combination n minus 2 4 n squared and 0 for the cube 4 and 1 minus combination n minus 3 choose 3 and cubed and 0 for the cube cubed and 2 over the cube plus combination n minus 4 choose 2 and raised to the power 4 and 0 for the cube raised to the power 2 and 0 for the cube minus combination n minus 5 choose 1 and raised to the power 5 and 0 for the cube raised to the power 1 L, of course, multiply by L4 of O the cube plus n raised to the power 6 times L5 of O the cube. Okay, now after simplifying this one, you see the series of 5 is an odd number, so we should appear the negative sign to be negative C15, okay, C15 times combination 6 to 6. Okay, this 6 to 6 is 1. That's why here down I wrote it is negative combination choose 1 because this is 1, no need to write it, times at 0 of O the q raised to the power 6 plus n squared at 0 of O the q raised to the power 4 and 1 of O the q. Why? Simply because the n is 6, 6 minus 2 is 4, 4 choose 4 is 1. Then minus n cubed and 0 of the q cubed and 2 over the q. Why? Simply because 6 minus 3 is 3, choose 3 is 1. That's why here we simplify immediately. Okay, the first term of combination is always 1. Okay, because 6 minus 4, 2, 2 choose 2 is 1. 6 minus 5, 1, choose 1 is 1. So I will just write the formula as it is, the change. Minus n, we thought we continue, minus n raised to the power 5, at 0 for the q, raised to the power 1 times L1, L4 for the q plus n raised to the power 6, L5 for the q. Now, learners, we just find the last value, the last formula. This formula has been simplified and has been derived from the discriminant formula of Mourad Sultan Ezouidi when k equals 6. We obtain the last one. Okay, now I will use, let's say, the given detail. Okay, this is L0. Okay, this is L0, Mr. Murad. Don't forget, copy and paste it here. L0 is written here. Okay, I will cancel this, cut. Okay, what is it? Enter, go up, make paste. Okay, now we go down, I told. Okay, so this is L0, L1, L2, L3, L4, L5. There is a secret in the Q, learners. Okay, if Q varies, means that you will get a new polynomial, okay, raised to the power, the new exponent, okay, the new power, okay. I explain this, inshallah, not next time, but after finishing, let's say, solving or giving examples for solving polynomial to the power 4, then 5, then 6, then 7, then 8, then 9, then 10, okay, and to summarize this research for you and to let this research, let's say, uh, on the right way for you to use. After that, I'm going to involve new theorems that are really very important and that are really unbelievable sometimes to work with. Okay, like the formula of Mourad Sultan Ezouidi. So therefore, we continue learners. Okay, sometimes my daughter, when I talk with her, she told, okay, okay. How can you say it? Okay. How can you again? Okay. Okay. So, but me, sometimes I told, okay. or okay, or okay. But I now, let's say, telling okay as my daughter told exactly. Okay, so therefore we continue. Just we close this parenthesis joke. Okay, now we continue learn this. Okay, proceeding. No, not like that. Okay. Okay, no problem. No, no, no. I'll change this one. Okay, okay, okay. So therefore learns I will continue finding the value of S5. After finding the value of S5 learns, okay, I will tell that I reach the last step. Okay, because the last step is very important. Okay, I should find this one, and this one is not easy to find it out. Okay, else you don't have a calculator. Okay, therefore I will give you time to use, or I will explain this using my calculator. Okay. After that, after solving these polynomial learners, I will give you suspense. Okay, I will give you something for you to know. Okay, now I will use the calculator. I will just make my calculation. Okay, enter exactly the box that I created for finding the value of S5. Okay, this is S5. I will start from the beginning. This is negative 5 plus 50, negative 20 plus 15, negative 26 means plus 26 minus 31. Why? Because 6 raised to the power 6 multiplied by 6 to the power 6 will be cancelled out. Then 6, 5 divided by 6, 5 cancelled out. 6, 4 divided by 6, 4 cancelled out. 6 cubed divided by 6 cubed will be cancelled out. So 6 squared divided by 6 squared will be cancelled out, and its value is 1. When you multiply any value by 1, you will get the same value that you start with. Therefore, and 1 raised to the power 6 or 4 or 3 or 2 or 1 or 0, you will get 1. Therefore, I will just write negative 5, okay, plus, because negative 5 plus 15, because this is 15, minus, this is minus 20, because this is a 20, this is minus, plus 15, plus 15, then minus 26 means minus multiplied by minus positive means positive 26. Okay, then minus 31, minus 31. This one, learners, has to be equal to 0. Okay, therefore, as 5 equals 0 means there is a remarkable, or no, let's say there is, okay, when S5 equals 0 means that the first value, which clearly should divide S0 by 6, because you have a polynomial with its highest power as x. Okay, now learners, I will just close this one. It's clear for you that I calculated. Now I continue now, summarize the whole work, okay, after, let's say, finding the value of S0, S1, S2, S3, and S4, and S5, okay, we should write our polynomial. This is a new polynomial, obtained from the original polynomial that is related to the L0 of all the cube, and this polynomial is related to the S0 SR of all the cube, sorry. Therefore, I will write this polynomial as learners. I will just make like that. Please, Julia Sormam. Okay, I will just write this. We told, in other words, S0 equal S1 equal S2 equal S3 equal S3 equal S5 equal 0, except learns S4 that we calculated before, and we find that is negative 32. That is negative 32. Okay, that is negative 32. Okay, it means that, please, my daughter, go to Ayub and tell him he has to reduce his voice, okay? Therefore, we continue. Okay, my son is playing, okay, and his voice It's very loudly. Okay, but okay, we continue. Therefore, learners, we just comes at this point. In other words, we call the S0, S1, S2, S3, S5 is 0, except S4 equal negative 32. We replace all of this value here in this new polynomial. Any polynomial that you are going to solve, you should come at this step. You should reach this step. You should find the new polynomial that will help you solving your original polynomial. Therefore, learners, I'll just write this as after writing p of x equal x raised to the power 6 minus s0 of order r x raised to the power 5 plus s1 of order r raised to the power x raised to the power 4 minus s2 of order r x raised to the power 3 plus s3 r x squared minus s4 r x1 plus s5 r equals 0. Therefore, all the terms we told from the beginning is 0. I will just simplify all of this as that p of x. This implies that p of x equal x to the power 6 plus s4 rx. Okay, equal 0 means there is a common factor here x. I can, let's say, okay, yes, x is a common factor. I will write outside the brackets. Okay, x means that here x6 divided by x gives x5 plus s4 equals 0 means x equals 0 or x5 equal s4 and s4 is a negative. Okay, therefore I will continue proceeding solving. Okay, this one I'll just write x5 learners is equal to s4 simply because, okay, just a moment, because this is negative s4. Okay, this is of course negative s4. Okay, negative s4 means that x, also this is negative s4. Okay, because this is the formula. Okay, so it will be x equals 0 or x raised to the power 5 minus s4 of order r equal 0. So therefore, when you transfer this one, it will carry with it a negative sign, it will be positive. Now I will continue, learners. Okay, I will continue solving. Therefore, we told that x equals 0, it's clear for you. Okay, meaning this is the root of the new polynomial. Okay, not the polynomial that I started with. Okay, the polynomial of, let's say, all the, okay, the polynomial that had been obtained from the discriminant formula of Mourad Sultan Ezouidi, HSM. Okay, therefore, learners, HSM means the name of my mother, and S is the name of my father. Okay, it's a brief call for my mom and for my father, and I thank them so much for what they had been for me. Okay, they bear life. Okay, in order to let me grow and, let's say, succeed, and they did everything for me. Okay, in this occasion, in this and this it's an occasion to thank them. Okay, and to tell them that I love you so much. Okay, so we continue. We told that x raised to the power 5 is equal to s4 of order r equal negative 32. Therefore, to find xk that belongs to 0, 1, 2, 3, 4, and 5, there is a 5 here, so it will be the fifth root of negative 32 exponential 2k, sorry, I pi over 5. Then I can write the negative sign as exponential I pi, learners, you see. Okay, because minus 1 it's equal exponential I pi equal cosine pi plus I sine pi. And sine pi is 0, it remains only cosine pi, which is minus 1. Therefore, and the fifth root of 32 gives 2. It remains now uh, fifth root of exponential I pi, meaning this exponential I pi has been raised to the power 1 divided by 5. Okay, here, of course, this is 5, Mr. Murad. Okay, then Okay. Mhm. Okay. We thought this is 2. Okay. Divide by 5. Okay. Now the. Okay. Okay. Or I will just raise this one. Okay. I will raise this one and make only this divide by 5. Okay. And therefore, I continue root cube fifth root of 32 is 2 in exponential I pi divided by 5 times 2k I pi divided by 5. So I have two bases with different indices, and the sign is multiplication sign. I should add indices. Means 2 times 2k plus 1 I pi over 5. This is the roots of my new polynomial, this one, not the original one. And in order to find the value of course, here, yes, here we found xk, and xk equals 0 because of this. Okay, therefore alpha, let's say k belongs to 0, is exactly L0 for the q plus x0, okay, which is equal to 1. Okay, because L0 for the q is 1 plus 0 over 6. So the first root is that, which is a real number. Okay, now I will continue learning for the other roots. I'll just use the xk belongs from 0 to 5. Okay, I will just use this one, mean that alpha or the root alpha indexed k belongs to 0, 1, 2, 3, 4, 5 is at 0 for the q plus xk 0, 1, 2, 3, 4, 5 over 6. So it will be 1 plus 2 exponential to k plus 1 I pi over 5 divided by 6. So these are called the roots of my original polynomial. Okay, and okay, what is it? Okay, yes, and this also, I will make another color. It's better if it is better, of course. Okay, so okay, good. Now, learners, it's clear that we already solved this, but this polynomial to the power 6. Okay, and k, for example, here you can see that when k equal 2, because k belongs to 2, 3, 4, 5, 0, 1, 1, it will be 2 times 2 is 2, 4, plus 1, it will be 5. 5 divided by 5 is 1, times ip is ip, then 2ip is negative 2, 1 minus 2 is minus 1 divided by 6. Also here I have one real number, one real roots, and here we have also one real roots. Okay, opposite roots. Okay, so we have two real roots. You can, let's say, check this one using calculator, and you will get the now. I mean that we solved our problem to the power 6. Okay, thank you for listening, and we hope so that this example, let's say, helps you finding the roots, or at least practicing the discriminant formula of Mourad, so that you can figure out all the zero or all the roots of any polynomial, okay, to the power 6. Okay, soon inshallah we can see you one day. Okay, thank you and goodbye. Okay, I'll just save this one. Okay, first. Okay, like that. Then I'm going to, okay, okay, if you want to check this one, learners, it's very easy for you. Just substitute x equal alpha equal 1 over 6 and alpha equal negative 1 over 6. Okay, you will get a now, meaning that it's a root. Please don't touch. Okay, now I will close this one. Thank you for listening. Okay, I will just close this. It is possible, of course. Okay, now I will end the stream, learners. Okay, end the stream, and